So this is the August edition of the Southern California Splunk user group meeting. We have Micah with us to talk about detecting network traffic anomalies with machine learning and to kind of give a quick thoughts and feedback. If anyone has any feedback or thoughts on the user group, how it's going, what you would like to see, future talks, anything really about the user group, feel free to drop us a line at the Southern California user group channel on Slack. It's at SoCal_user group. And we'll be sure to make some changes if you'd like to see something new or like to see just some fresh ideas in the user group. So with that, we'll kick it over to Micah.
All right, thank you, Sean. Let me share out my screen to everyone. How's that resolution looking?
Looks good.
All right, let's get rolling. So thank you, everybody. My name is Micah Gaither, sales engineer with Splunk. I'm just down in San Diego, supporting the Southern California region. So I see some familiar names out there and digital faces. Happy everyone joined. Today we will be talking about anomaly detection, in particular network outliers. That was brought up in last month's section. So we'll be tackling that today. So just to kind of recap, so last month we did a lot. We covered a lot of material last month when we were talking about MLTK. We were talking about the app itself, why it's cool, why it's awesome. We talked about what's new in it, and then we kind of pivoted to some clustering over here on the right. What's the first question in data science? Well, what is the question? Of course. Well, sometimes you don't have it, right? So that's why I wanted to show you a clustering exercise using MLTK last month. I thought that was neat. So we looked at k-means, where you have to define the number of clusters. Maybe, I don't know. We looked at g-means, which new to MLTK, and x-means, which will give you the number of centroids or clusters. So that was a lot of fun. I actually did anyone, I'm going on a limb here. Did anybody actually try any kind of clustering activities, exercises, just look at the clustering showcases in MLTK? That's fair. I don't blame you. You've got other things to do. I get it. But I still encourage you to do it. Take a look at it. It's pretty darn fun. I was working with a customer not too long ago, and we did just that. We looked at some Windows machines. So that process that we kind of reviewed last month of get the data in, normalize it, reduce the dimensions, do that principal component analysis, and then start clustering. Well, we did that. And if you think of all the features that make up a Windows server, right? Specifications, if you will, fields, and reduce that down, what we found out was that there was an outlier, right? There was a machine that was clustered that didn't belong in that cluster, and it was because group policy was messing up. So from a performance perspective, Windows is probably going to crater at some point because group policy is just bouncing back and forth. That it was in limbo on the domain is of concern, right? If I can't push group policy. So you never know, right? So that clustering may spur the questions that you didn't know you even had. But today we'll focus on this anomaly detection. At some point we should do some predictive in the middle. Time series forecasting, it's always a good time, right? We always want to look into the future. What does that look like? I tried to predict the score of a Padres game the other day, and I was 2 runs off, and Vegas was right on with the over/under. So no matter how good your math is, sometimes Vegas is even better. So in regards to this topic today, the anomaly detection, I had a colleague ask me, hey, Micah, is this going to be, IT or security specific? And I said, it's everything, right? Everything can be anomalous, or at least is a source of data that we use to determine if something is anomalous. So while you're kind of listening to me and we go through some exercises and you're daydreaming, think about some use cases, right, that you might take, that you might go back to work or maybe use at home, right? What are my solar panels looking like? What is my energy consumption? Or, the metrics data all around us, right? So what I'm going to do today is I have a few of these slides just to level set. I know, the slides are really for the best because it keeps me on the rails. So that's a good thing. What I'll do is we're going to talk about this anomaly detection or outlier detection, which, by the way, I didn't know this coming in preparation, but they might be synonymous in some conversations, but in others, an outlier is not necessarily synonymous with an anomaly. So an outlier might be something of the data coming in, right? That is an outlier. And an anomaly might be something of the data coming out that you're consuming that is anomalous or an unexpected behavior, right? So if you look at like temperature of the United States, Alaska will show up as an outlier. Is it anomalous? No, that's Alaska for you, right? So I thought that was neat. I had to look that up. I wasn't aware of it at the time. So what I'll do is I'll show you in SPL how to do this outlier detection. And we'll do that all through SPL commands. And you're going to be very under impressed with how simple this is. It really, really is simple to perform. So I encourage you to give it a shot. Go out and do it. We're going to use this density function. And just let me pivot quickly over to Splunk and show you this density function that we're going to use. Get over your browser. So don't laugh at the number of apps I have. I used to have many. This is a new laptop. I burned out the other one. But so MLTK, right? We looked at this at exhaustion last month. But again, I encourage you to come in here. So for detecting outliers, look at the examples, right? Go through the Smart Assistant. Come in here. Take a look. Look at the SPL that's rendered as we go through here. You're gonna recognize, right, this distribution type, this tolerance threshold, and the SPL as we walk through how this works. All right, this is using the probability density function. It's just abstracted for you, right? That's the purpose of the Smart Assistant. So keep that in mind. Moving forward, why this density function? Well, let me tell you why we're going to do this density function, because, you know, a lot of times if we're looking for outliers, a quick and easy way to do that, right, is just, hey, show me in standard deviations. What's 2 standard devs out? What's 3 standard devs out? And if it's outside of that, I'm marking it as an outlier. That's something anomalous to me at that point. Well, that's assuming you have a normal distribution. And we'll see that out in nature. Mother Nature provides that a lot. But I can tell you, I don't see a lot of normal distributions in technology, right? Be it IT data sets, InfoSec data sets. It's usually something multimodal, bimodal that we run into. And so this is where this probability density function is going to help us out, right? So if you remember our basic stats, or even if you don't, right? This is what we expect a normal distribution to look like, and then the standard deviations going out, right? Majority will be within 1, vast majority will be within 2, and then there are some oddballs like me that might be 3 standard devs out. But again, we're assuming this normal distribution, okay? So what if it's not? What if it's not normal? It's probably not normal when you look at your data. It's probably something like this, kind of a bimodal, where the average, it's not so average. Now, is it? Right? This might be working hours over here. This might be off hours over here. It's important to understand because you are in such a powerful position as the subject matter expert to interpret this data, right? No matter how high of an order the math and statistics skills of a data scientist are, you're the one that understands the data, right? Ultimately, you're the one that understands what's anomalous, what is an outlier, right? So this is where this density function comes into. If the data isn't normal, we use this probability density function, and we'll draw a curve that's more appropriate to your data distribution. Love it. Thank you. So what is this thing? What is this thing? Well, it's pretty simple, actually. So density function is a function to which we'll pass some parameters, but what we're determining is the likelihood right, of something living within this curve, right, within this function that we define. So something exponential here, we can say that it's more likely that I see a 1 than a 3. It's more likely that I see a 2 than a 4, right? And we can tune that threshold as a parameter that will pass to the density function algorithm, and we'll look at that in the SPL. Right? So this density function is looking for distribution types, something exponential like we just saw. Of course, the good old normal, which isn't so normal in our fields, atypically beta, but more often than not, something Gaussian kind of like this, kernel density, like down at the bottom right. Okay. So what it's going to do is we're going to feed it this data. And now you can define the distribution type if you want, or it will determine the distribution that it thinks fits the best, right? We'll apply this density function. We'll apply a threshold to it, right? We'll tune it to get the number of outliers that makes sense. Because again, we are the SMEs of this data, right? How much is noise? How much isn't? And then it'll kick out a model, just like we saw with MLTK last month, right? Fit that algorithm, apply that algorithm, or excuse me, apply that model. So there we go. So now that we have our model, the data comes in, and we determine the likelihood of the data fitting our model, fitting this density function that we've created. Quick tip, don't fit on noise. Make sure you have enough data coming in. I'll show you a summary command. You can check the cardinality of this data, all right? But as always, right, you need to have enough data to represent the environment. How much data is enough? Depends on the use case. What are we trying to do, right? Is it enough to show the seasonality, the trending, right? That's where, again, you as the SME, you have that awareness, right? There's a capture end of month processes, quarter end, that kind of thing. Just another quick note, beware of this mysterious shifting mean, right? So if you have cumulative data, right, in this distribution, so the number of logins per month at day 5 versus at day 25, that mean is going to shift, right? So we're shifting from, maybe this is a 1 over here at logins per month on day 5, but by the time we get to 25, we're closer to 4, 4.5, something like that. So again, you as custodian of the data, of the citizen data scientist, this is your awareness and your responsibility, and you're the one that truly understands how this all works out. And then kind of finally, the mlspl.conf, if you run into any settings you need to tune, they're all in this mlspl.conf, which is accessible either through an editor, of course, or within the machine learning toolkit itself. So let me show you that, because if you, like myself, run this on your laptop just to test things out, you're going to want to be able to come in here and tune some of the parameters, right? So we're definitely going to look at this default probability threshold. We'll be changing that as we pass that parameter to the algorithm. So just be aware of that when you come in here. Okay. Using the density function. So what I'm going to do here is I'm going to break this up into, I'm going to pivot now into Splunk, and I'm going to show you how to use the density function. And then I'm going to come back here and just review kind of a takeaway that I'm going to give you on a different data set, but then you can come in and apply the density function following the following slides and determine your own outliers as an exercise. So I think that's kind of a fun activity. So I'll show you those after I give you the demo. And in all your copious free time, you can run the density function on your own. Okay. So let's get to the Splunk. Let's get to the good stuff, right? So just a couple call outs before we start diving into the SPL. I showed you this before, but if you don't remember, all these algorithms are under the ML documentation. Come on, Google. Right? So what's nice about this, and the only reason I call it out is you can come in here and look at the algorithms by type, what you're trying to achieve, right? So anomaly detection, there's our friend density function. And this reads like a tech manual. This reads like Splunk documentation. What it does not read like is this documentation. This density function comes from SciPy, right? In our Python for scientific computing, the Python interpreter we use and we looked at last month. Would you rather read this? Oh, I don't think I can read this. Or come in here and go, what is this density function? What are the parameters I pass to it? Oh, partial fit. Existing model can be incrementally updated. That's pretty great. Incrementally update my model? Yeah, yes, please. I'll take a serving of that. Right? One other call out is, when you start to do some of these explorations, sometimes you're looking for data sets, right? And again, go to that showcase, go to those examples that we have to get you started. But there are great data sets all over, that Google has, that UC Irvine, right? And these are all the data sets that are included with the machine learning toolkit, right? So this one we're going to look at today for network outliers is this internet traffic data set, which is, I believe it's free to use if you just do a citation. Oh, yeah, free to use with a citation, right? So come in here, start working with some of these, or bring your own in as a lookup, right? Maybe that's how you get into this stuff. Okay, let's get to it. What I am going to help you out with is I'm going to drop some of these searches in here, and we'll just walk through that internet traffic data set. I'm going to spare you my typing because I will most definitely fumble something, and then we have to work through my typo. All right. So this is the internet traffic data set we were just talking about. Super simple, right? It's just time series data, right? With this number of bits transferred over time. Not a lot going on there. You can see this is like a classic. We use this for time series forecasting, which would be another great exercise. And you can see why, right? You can see the seasonality here. Monday, Tuesday, Wednesday, Thursday, Friday, weekend, Monday through Friday, weekend, party. But we can still use this to look for outliers, right? Look at these little tippy spikes up here that are anomalous. So we're going to use this data set to look for these network outliers. All right, is everybody tracking? We're going to get some outliers here. Sound good? All right, settle down, everybody.
Sounds good to me.
Settle down, everyone.
Oh, no. Okay.
All right, so here we go. Now we're getting some fun now. So remember, the data distribution is so important for this probability density function that we're going to use. So let's look at the data distribution. How do we do that? Well, we do that with a histogram, right? So very, very simple histogram. I'm bringing my data in. I'm going to throw it into buckets. Here are my bins. Stats count. I'm going to make this continuous, right? On this x-axis, I want to fill it out, right? Make continuous, and then I'll fill those nulls with a 0 if I have to, and I'll just sort the thing. Not bad, not bad. Here's our histogram, but let me show you. That's retro histogram. And if you Google enough, you'll find that. But here we go. We have a histogram macro. Hooray, 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 right? So we'll just bring our data in. Again, this can be an index. You can do some pre-processing to the data from that index. It could be a KV store, whatever. We're going to bring the data in, and we'll pipe to this histogram, and we'll start looking at this data. This macro, actually, let me show you that. It's part of the machine learning toolkit. So if you don't have it, you're going to want it to run this macro. So it's going to be in here somewhere. There it is, histogram. And look, it's my previous search, right? So there's no magic going on there, right? But why remember those 5 lines or stick them in Evernote if you don't have to? Hooray, histogram macro. But let's look at this histogram. Is it normal? I don't think it's normal. Anybody think that's normal? I'm not thinking it's normal. If I were to like make some inferences about this, and this is network traffic, most of this is over here. This might be off hours. This might be during work. I don't know. This is no man's land down here, and this is people doing torrents or something on the high end of things. Right? I don't know. But again, here's the SMEs. You're going to know, or at least have a better interpretation of what's going on with this data. But we do know it's not normal. And we do know that's great for the probability density function. And we do know that just applying 2 standard devs out on this data set's probably not going to be what we want to do. Right? So what am I doing now? Well, now I want to look at the distribution of our data if it was normal. So again, I will bring my data in. I'll do my fit command of the density function. This is the algorithm that we're calling. And you recall the fit command from last month, right? Here's our field. I'm going to define a normal distribution in this case, right? And the reason I'm doing that, and then I bin things, I do my counts, I'm going to make this probability density field here. I'll do my make continuous and I'll sort it. Let me show you why I'm doing that, because I want an overlay. And thank you, field. And I want you to show up. Yes, there it is. Definitely not normal, right? This is what normal would look like for this data. So we're not there. So as I said previously, this is a great use case for the density function. So let's apply it, right? I mean, this is pretty darn simple so far, right? Same thing. I'm going to fit my function. I put this head in here because I don't want that warning for 10,000 data points in my visualization. That's the only reason I inserted that in there. But I'm going to fit this density function algorithm. Notice I didn't set the parameter for the distribution. I'm going to let the algorithm select the distribution. I have a pretty good idea what it's going to select. I bet you do too from the slides we just saw. I am going to set this threshold. The threshold by default is 0.01. So it is 1% that we're looking for. This is tunable, and you will be tuning it, right? So, but I call it out here because we're gonna work through this tuning of the algorithm, and then again, I'm going to just put it into a model. We looked at this last month, right? And we run it. So I fire off my algorithm. I've got my algorithm going. It's created my model. I now have a model, this density function model for internet traffic. I can now apply that to searches as they come in. I can partially fit them, right, as we saw in the documentation, to future data sources that are coming in, or data that's coming in from this source of internet traffic. It's pretty good. I'm going to change my overlay. And by selecting the is outlier that we created, I now see I've identified some outliers. I got this rascal on June 7th. I have 11 outliers that it's identified. We come over here and look at the stats, and we start to look at these outliers that it's identified. So here's our guy on June 7th that I picked out, this little rascal here. Gotcha, pal. All right, at 155, right before 2. And I see that the bits that were transferred here, 8536-8675309, that's Jenny's number. And the boundary ranges that the function determined. So less than 8189-36575, greater than 845, right? From infinity here So less than this number, greater than this number, greater than, that's this guy. We nailed him. But maybe that's too many. Maybe 11 outliers is noise, right? That's where you're going to use this threshold number, right? Maybe it's not picking up enough. So I can turn up the threshold, right? It's at 1% right now. So it's just grabbing these little spikes in here. If we look at our friend, it's just grabbing that little spike. But I mean, that tiny little hair on the head, it detected at 1%. It's not bad, not bad. What else is good is this guy in the valley. Right? It's too low. We grab this little dip, right? So we're getting the upper and the lower with this density function right now at this setting of 1%. Now, I can tune it and I can say, well, what if I do 0.5%? I don't know what's going to happen. We're going to see what's going to happen. But this is where you come in now as the operator, the owner of this data coming in here. And you see I dropped the number of outliers to 6, right? So I can keep coming in here. I can keep tuning this threshold number, right? Until I get something that I think I can operationalize and action on, right? And now this creates the questions of what was happening here, right? What happened June 13th at 10:10? Right? Your data probably can be a little more rich. You could probably have a MAC address or something, right? And you go, where's that MAC? Let me look at my assets, my inventory. Who's got that MAC? Who owns it, right? Now the questions are formed. Now you've got something to go after. And you got the data in Splunk. That's the magic right there. You've got that cross correlation. Track down root cause. What was happening on June 13th, 2005? Okay. Not bad, not bad. Let's explore this data a little more. So does that make sense, right? Now, I just have a Splunk search. I have a Splunk search that I can apply, right? I can create a scheduled search that applies this model I created. This model I created right here. And I can run it, if I want to run every 5 minutes, I run every 5 minutes to the data as it comes in, you know, to maybe a certain index, right? Apply that. Hey, alert me if this is outliers greater than 0. Send me an email or send it to my colleague. Let him, her, they, them work on the ticket. Right? So, I mean, that's pretty fast to operationalize, right? Pretty fast there. Let's take a look at our data, though. Here we go. This is our density function that we've created right here, right? So look, I'm bringing my data in. Again, I just want the 9,000. I don't want the warning. I'm going to apply my model. I've already fit it. I've already created that model previously. I'm just applying it. I'm going to bucket it. I've got my histogram, quick count, make it continuous, sort it, and apply this density function here, okay, against my histogram. Not bad. Not bad. Easy stuff. Something I would look at now that we've got a working, not a working dictionary, now that we have a working model, I would just come in here and I would just do a summary of your model. All right. So I would just do a summary of my model. Remember, we put this on auto. We didn't specify the distribution. Right? I did when I wanted to show it against normal, but we let it pick it itself. Of course, it came up with Gaussian. Right? We saw that already. We made that determination a long time ago. But you get some stats now against your model, min, max, mean, you know, et cetera. But this cardinality is good to look at too. How do I know I have enough data in here? We know I did that head of 9,000, so that makes sense there, cardinality 9,000. So, but it's iterative. It's iterative. Go through, keep tuning that model, and until you get some, you know, something that makes sense with the outliers, both the over and the under of that threshold setting. So, what do you guys think? Not hard to do, right? Not as kind of maybe esoteric as some of the clustering might have seemed last month. What do you think? All right, that's fair. I put you to sleep. I'll take it.
It seems good. I'm kind of curious if you had more features than just bytes transferred, what that would look like in finding anomalous activity in say a multi-feature data set.
Yes. So remember the have faith. Have faith in documentation, right? We can come in here and do a buy of these, right? We can create multiple models and apply them, right, to these boundary ranges. Here it is. By field, by field, by field, by field. It's super simplistic, right? We just took the number of bits. But you want to take multiple fields? Yes. You want to start something time-based, right? And you say, well, I want to do it by hour. I want to bucket these by hour. I want to bucket them by day, right? By type of day. Is it a work day? Is it a non-work day? Right? Big influencer? Yes. And you put that in your model. Right? Absolutely. But I would say, start with something simple here, and that's why I have these slides in the back that I'll give you in this deck. Right? You've got this app request CSV, and notice multiple fields. So you want to go there? You can go there. But this is going to walk you through exactly what I showed you, just a different data set, where it's going to pick app 2 in this case. But, go crazy. Do app 10, do app 7, do a combination of apps, right? And start practicing on creating a model that fits well to give a number of outliers that you think is practical. And this isn't your data, so it's subjective, right? But you're going to walk through the same exercise of, I got to understand my data. I got to visualize my data, right? I got to set my thresholds. I got to find my outliers. At 1%, 0.01, 74 outliers. It's probably too many. I can't action on 74 outliers. They're going to have you tune at some point. Here we go. We'll tune it. We'll go to 0.5%, 0.005 there. There's our threshold setting, right? 40 outliers. Probably still too many, right? Days apart, yeah, right? So you just keep tuning. Walk through and understand this data as an exercise. Use these data sets. Use the data sets that I showed you that are included with MLTK. Start looking for these outliers. And so I'll give you these slides, and you can, it's a nice tutorial, right? Yeah, just like I was saying, just do an hourly split on here. You're going to do it every 4 hours. Absolutely. Right? Make sure you have enough data. And that's it. Not bad. Pretty painless, right? So we'll have the deck available for anyone that wants to walk through as an exercise. If you were doing that daydreaming I recommended of thinking of use cases, thinking of data sets, reach out to your friendly neighborhood SE and let's walk through it. Walk through it. Reach out to me. Let's have some fun with it. Let's enjoy the data. So thank you for your time, everybody.
Thanks, Micah. Appreciate it.
Thank you, Micah.
Yeah.
All right, everyone. Next month's meeting is on September 22nd, same time, 4 p.m. I'll be presenting on the World of Warcraft economy and how it was splunked. It's pretty interesting talk, if I do say so myself. Ha ha ha. But I think it's something that you can get some use out of too. So thank you again, Micah, for presenting last month and this month. Absolutely incredible information. And I hope to see everyone next month. Thank you.
All right. Thank you, everyone. Bye.